Well, we're just going to keep, as I said, we're going to keep things informal. Just a little bit of background. If you did attend the imagery management workshop that was just done back about an hour and a half ago with myself, you'll see some repeat stuff here. It's we're going to kind of give the same presentations, kind of the same background type information. We do have some updates to that. We actually recorded that workshop a few weeks ago, and there has been some fairly significant changes. And so between Jeremy's presentation and Dave's presentation, you'll see a little bit of differences. But if you did sit in on that workshop, you might see some overlap. So I apologize for that. So please decide if you want to stay with it or not. By all means, hopefully there'll be new information for you. But what the whole goal today is, once again, please, if you just joined us, please mute yourself, so we stop the feedback a little bit. Thank you. If you just joined us, we have some significant new capabilities for you to manage and start working with your imagery. In the past, we've relied on the image server, which requires an enterprise setup. It's a it's a full up capability to set up a enterprise server with an image server and start publishing all your different imagery services and those types of things. And that can be daunting for a lot of people, especially if they have to coordinate these things through their IT departments or whatever it might be. And so we've been searching for ways to make this easier and simpler for our customers. And the way we're doing that is with a new capability. We call it ArcGIS Image for Online. So once again, getting a little bit of feedback. And so what we do is we're going to show you that capability. But before we do that, we want to show a implementation of the image server that we put together for FEMA in support of last summer's hurricane season. And so we're going to go through that and show you how that was done and show you some of the capabilities behind imagery services and how that all works. And Jeremy's going to give that presentation, and then we're going to switch over to Dave Wright, who's going to talk about this new capability of being able to set up a similar type system in ArcGIS Online. So with that, let's go ahead, and I'm going to turn it over to Jeremy. And Jeremy, if you want to go ahead and give your presentation, please.
Sure. Can you guys see my screen?
We can.
Okay. So yeah, as Kurt mentioned, we'll talk a little bit about what we did specifically for FEMA with their imagery management solution last hurricane season. And so Dave's going to get into talking about different patterns and practices for how you can manage your imagery. And this is just one specific implementation. We've done other types of implementations for other customers. So for this particular one, we're going to be talking about enterprise with image server. For FEMA, they had a federated image server and portal. So everything we were doing through image server was pushed out through their portal, which was kind of the front end for their analysts to find and get access to the imagery. So if my screen will cooperate and move forward, I can move on. Okay, so one of the biggest things for them is they get all kinds of different sources of imagery to include satellite and aerial imagery, and then even beyond that to some standalone images, 360 degree, and then 3D data sets as well. So it's really the biggest problem for them is a centralized storage and dissemination repository so that their analysts know where to go. Typically, this analyst needs this type of imagery. They would go search for it, find it, download it, bring it in, and work with it locally. But by setting up an imagery management system that we could start pulling those data sources in and managing it and pushing it out through this centralized storage process with a front-end discovery application that lets them really find exactly what they're looking for and start working with the image services rather than everybody getting access to the raw data and working with it on their local system. And the idea was to get these services so they could be ready for analysis. So early on, they were just working with some custom raster functions, but the long-term goal is to set up some GeoAI capabilities within their enterprise. So the data comes in, these GeoAI tools are ready to run, and they can just do the deep learning / machine learning / GeoAI type analysis on those services as the services become available. And then another important aspect is managing that access. They've got all kinds of different users, and they want to be able to do, certain capabilities with certain users. So Portal provided that front end to let them control who had access to what, who could see what, and then who could do what with each of the data sets. So for them, like I mentioned, there was one particular implementation pattern, theirs being a federated image server with enterprise. Most of their storage was being done in S3. So I mentioned that the data sets were coming in from a wide variety of sources. Some were being downloaded from websites, others were being transferred via FTP. And the whole process was just getting them copied over, pushed up to the Amazon S3 bucket, where then we were curating and building the Mosaic data sets in ArcGIS Pro and publishing services to their image server from Pro. It's a pretty standard cloud-based implementation. And one of the bigger challenges was they had all these different types of imagery coming in, right? So, in this case, we're going to be talking a lot about image services on the back end, but, besides just image services, these guys were working with individual geotagged images. When they go up and fly, sometimes they aren't able to collect the type of imagery that will be turned into 2D or 3D orthomosaics or 3D meshes and point clouds. So they would have just individual images taken out of aircraft, or they wanted to be able to see those. So we'll look at some examples of that. If they did have access to roads, they would sometimes drive up and down the roads with the 360-degree cams. So we had to bring those out. And then I mentioned aerial imagery from providers like NOAA and the NICB. When they go out and fly, they produce nice aerial imagery. And then also the satellite imagery. They were getting next view program data from Digital Globe. They got some Airbus data. They were getting some stuff from Planet. So just being able to bring all these different sources in and overlaying it and making all of the stuff available so they could decide which one was going to best suit their needs. And then the last one was the 3D meshes and point clouds. One of their big providers is the Civil Air Patrol. And so they have this new Waldo Cam system where they're flying, and they try to fly a pattern that is able to produce good 3D meshes and point clouds using photogrammetric software. So we're starting to work with them to produce these things in SiteScan. And so once it's published or processed there, then we can push those services out to their portal as hosted scene layers and things like that. So here's just some of the different applications that we provided that we'll go into more detail in part of the demo. And of course, one of the big things with FEMA is speed and access to these data sets. So I mentioned right now we're using the one implementation pattern, but going forward, now that we have other capabilities like the hosted, the ArcGIS image for AGOL, whatever the name convention is right now, Dave will go into that in more detail, but there's other implementation patterns that might work for different scenarios for these guys in particular. So where these guys are updating services quite regularly, this current implementation works pretty well because we also have the ability to set up some automated processing. So for data sets like NOAA, where we know where to find them, we can just pull them down automatically from the website, have scripts and geoprocessing services set up to pull the data down, publish it through the Mosaic data sets, through GP services, and then update and overwrite the services each time that NOAA produces new content on their site. So as we got more and more into each of the different types, we can set up additional automated steps to make this process as hands-free and quickly as possible, so they get the data as soon as possible. With that, I'm going to jump over just to a couple of the apps that we built for them to help them access the data. Like I mentioned, in emergency situations, you don't want to have to go out and try to find data and download data. Depending on your internet connection speed, some of these data sets are rather large. And so getting them locally, one, just downloading something that size and then storing it is kind of a pain in the butt. So, we were doing that with a very high speed internet connection in the cloud. So everything was published out through their portal, right? So each time there was a new event, it would basically come in here and change the front end page so they could get the most current and most relevant information for that particular emergency response situation. And then as you dive into the portal itself, for each new event, we would set up a new folder. So that way, when somebody came in, these groups would be set up and they could easily go through the different folders, click on it, and get access to the information and the services and products that were available for that particular emergency. And then just using out of the box web app builder tools, we published some of these pretty basic applications, but each one really served kind of a specific purpose. And this particular one is just a footprint map. And a lot of people want to be able to see what coverage they had for any given event. So for this particular event, we're looking at Hurricane Delta. Just by quickly looking at the colors and the names of the services, you can see which content they had available. And this one was really nice because, as mentioned, this one was set up through their ArcGIS Online organization as well as a portal to ArcGIS Online collaboration. So every time we publish something to that particular group, it would go out to their ArcGIS Online users as well. And it was good because they have license restrictions on some of these data sets. So being able to see what's available without actually getting access to the pixels, we could share these with more users. So as you can see where the real hotspots were just based on just the footprints for the different services. And this one, again, straight out of the box, web app builder application. All these services are just loaded into a web map and then published as an application. And again, you can quickly see not just where you have coverage, but what the pixels actually look like. Because you can see some of these data sets, and typically the issue with some of the satellite imagery after the events is cloud cover, right? So now I can zoom in, I can turn on these different layers and turn them off and see what services I have, what's the coverage look like, and then if it's if it's got too much cloud cover to make that imagery usable. So again, different type of app, but also serves a different purpose. Now the analyst can see, yes, I have this WorldView 2. I know the resolution. I can see that it's pretty cloud free. So yes, I can use that. Or if it's too cloud covered, I can find one of these more high resolution services and use one of those. So this next application is what we call our image discovery application. And it's the only one that is not straight web app builder out of the box. This one has a custom image discovery widget that is available on GitHub. So you can get access to this widget in the source code. But this one lets you search across a bunch of different services. So while we were pushing the desire to have the users consume services and do their analysis against services, this one provides a nice capability that I'll show you in just a second. So now each one of these records in the table of contents is a different service published. So you can see for each event type and who the provider was, which content we have available. And it gives you the ability to filter your search by dates, and then different search capabilities by the current extent of the map, bounding box, point and buffer, and then coordinates if you're looking for a specific area. So I can just grab a bounding box, and it's going to go and it's going to search across each of those image services, querying the footprint table of the mosaic data set behind the image service. And I start to get results in my map. And you can see the various metadata that's available for each of these services. These are all easily configurable. You can pull in whatever metadata is available with the image service. Now, if I want to filter my results, I can filter out by source. And if I hover on the thumbnail, you can see the footprint on the map. And if I click on it, I can zoom in. And then from there, I can even preview the images and get the full resolution image on my map. So again, it's very focused. You know which area you're looking for imagery. You know which sources you want to see if there's in that area. So it lets you query against a bunch of different services and see what's the best available at that time. And then you can filter your results as well. But the one thing I mentioned, sometimes analysts do need to take some of these services for local use if they have a model that doesn't run inside of the Esri platform or a third-party program that they need to run these image services or the imagery capabilities through. Then they can add these images to their shopping cart and take them out and download and then use them locally. Or if they want to just create a web map from the subsource of the images that are in their shopping cart, they can create a web map and save it to their the configured portal. So those are the ones that are consuming image services. I mentioned they also have 3D, so I'll just quickly look at some of the 3D layers. This was a LAS point cloud published to their ArcGIS Online hosted, and this is from the Civil Air Patrol data. So this was run through a bunch of still images, run through a photogrammetric package, which produced this point cloud, which is now hosted in their ArcGIS Online organization, and then registered to Portal as a hosted item. This one's obviously rendered using elevation values. Here's another point cloud. This one times rendered as RGB values. As you click around the different thumbnails, you can jump through the web scene and see which data sets are available. And again, this for each event, we would create a 3D scene that would load all of the 3D layers. And again, they could easily find which 3D data they had available for that particular event. And for some reason, this one looks like it doesn't want to render, but give it just 1 second. It's a really nice mesh, so I'd like to show it. Sorry, I'll have to keep moving on. This one, I mentioned that they get a lot of standalone images. So they use Survey 123 for analysts that are out on the ground and looking at particular locations. They can take standalone images and upload those. But they also fly in aircraft and take images out of the window of the aircraft. And so those wouldn't be used and wouldn't be pushed to orthomosaics or stored in a mosaic data set, but they still want access to them. So we run them through a tool and then produce something basic like this image attachment viewer. And so now they could just click on each of these images and zoom in and get just a visual analysis of an area of interest. And then the last one I'll mention is the oriented imagery catalog. So this was a 360-degree cam. And here they had access to the roads pretty early, so they were able to drive up and down the roads. And then each of these still images, they have orientation information, and they're from a 360 cam that we support. So these get loaded into an oriented imagery catalog. And then when you build that OIC, you can see where the coverage is, and you can click on a map, and you can see all the exposure points, and then it pops up the image in this particular little viewer widget. And as you pan and zoom around, you can see, because it knows the orientation of the camera and all that information, as you pan and zoom, you can see the angle, which way the camera was facing, and get the full view and do their visual analysis that way, which again is nice if you have access to roads. This same oriented imagery catalog can be used for things like drone images as well. So. And the last piece I'm not going to bring up right now, but because all of these things were being published out through their portal, a lot of their pro users would then open up Pro, search through the content in their portal, bring the services in there, and then run those analysis tools that Dave's going to show, working directly off the services. So again, it's just nice for them to be able to find and then use across the platform all the different types of imagery and services that were available to them. So with that, I think I'll pass it back to you, Kurt, and you can see some different patterns and practices from Dave.
Outstanding. That was great, Jeremy. Question for the audience, or questions? Anybody have anything that they want to ask for Jeremy? Go ahead and unmute your mic. Excellent. Jeremy, how much data were we talking about that you collected over the summer, just roughly? You're on mute, Jeremy, you're on mute.
Didn't mean to do that. I think we got just under 6 terabytes total so far. Yeah, okay, so that's everything that's in S3. There are some data sets that are living on some of the servers, but S3 storage is about 6.
Perfect.
And I also should mention that CAP, a lot of their data, they already put it into an S3 bucket. So via an ACS connection that Dave is going to show, we were able to connect to their publicly accessible bucket and start adding orthos to mosaics in this environment, but we never moved the data into the FEMA environment that we were hosting. So with that cap data, it probably would have been, half again as much as we already had. So,
Yep.
But it's just the ability to see it in an existing bucket and leverage it there and not have to move it. That was extremely helpful.
That's great. So basically, what you're saying is you got your own curated data that you compiled and you built mosaic data sets for. And I know you did that like with the NOAA imagery, where you actually were pulling in the NOAA imagery and then republishing it as imagery services.
Right.
And then you also had other instances where you were just pointing to somebody else's S3 bucket and then building the imagery services against that.
Exactly. Yep.
And then you had other cases where you just pointed to a service, right? Somebody existing service like the Vexel imagery.
Yeah, exactly. So Vexels are using image server and pushing all of their blue sky and gray sky in this case imagery out via services that FEMA has access to. So yeah, we would just register their service URLs in the FEMA portal, and then we could consume them in all of the applications and things that we were setting up for FEMA. So
that's great.
Yeah, and some of that stuff was also coming from AGUL. I mentioned that CAP was uploading the 3D products, the meshes and point clouds, to their ArcGIS Online account. So then we would just turn around and register those as items in our portal. So when they bring it up in the FEMA portal, it was pointing back to ArcGIS Online, where it was already hosted once, instead of us hosting again, because some of them were very large. Those were, I think 10 gigs for one of the meshes. So yeah, we didn't rehost if we didn't need to, basically.
That makes absolute sense. But it's great that we can federate those things and be able to access it all in a single instance of portal. So it's right there and available to everybody.
Mm-hmm.
So what you saw here is a high-end solution. I mean, when you set up an enterprise server with image server, you can pretty much handle any type of application where you're dealing with large volumes of imagery, where you need that speed of delivering services, those types of things. So this is a complete solution. But we've now started to make things a little bit simpler for our customers. And that's where we get into this next layer of products, if you will. And that is this new ArcGIS image for ArcGIS Online. And we're going to have Dave Wright go through, give us some background information. Some of this is brand new. We just kind of decided product names as of last week. We've been working on kind of how the business model is going to work for implementing this solution. So this is fresh off the press stuff. But I'm going to have Dave give a little bit of background and then kind of walk you through and show you the fundamentals behind using this new software and how it would work. So Dave, if you're ready, I'm going to turn it over to you.
Thanks, Kurt. Yeah, so I need to share a screen. One second.
Nice timing.
So I started out earlier talking about basically how you could publish image services in the past. We were limited to this one pattern using ArcGIS Enterprise and specifically an image server in that federated cluster. And really how this has become simple with the latest versions of ArcGIS Pro. The example here is we have TIFF images in a bucket in S3, and really just creating this cloud storage connection file provides us the linkage to use that as if it's a virtual drive that we're connected to, even though it's sitting in S3. And to be able to drag those into the map or to add rasters from this location and create a mosaic data set, which is what you see here. And further, if you mirror that connection info on the image server, that's all you would have to do to be able to publish that as an image service. So right click and share as a web layer, right clicking on the mosaic. And then you have this image service that you can consume in your web applications, web maps, and all around the ArcGIS system. So we talked about this pattern. This is the one that's been around for many years and has these requirements of deployment and kind of administration and configuration. Well, this new pattern is exciting because it doesn't involve a great deal of knowledge around managing mosaic data sets or this infrastructure. It empowers people who have content to share image services directly just by uploading the images. So this is this emerging pattern, ArcGIS Image Online. And, you know, some people say, hey, we're really most interested in open data sets that live already on the cloud. We're not going to download those and upload them again. Just wouldn't be practical, nor if they're already managing their own data in a cloud environment. So this is kind of the answer to that is the image dedicated pattern where the infrastructure, the application here is still provided as a service. It's just not multi-tenant, and it's dedicated just to your workflow, your business, and your projects. So with that, yeah, I could demonstrate a couple of patterns. Here, Jeremy mentioned this cloud store. And this is where, you know, you can use these ACS file connections to browse your organization's data, wherever that exists. And we support connections to many different cloud providers. Let's just take a quick look at this together. The service providers include Azure, Amazon, Google Cloud, Alibaba, and more. And once you have them, you basically just browse it as if it were a drive. So what I've done here is to just create a mosaic data set from 5 different years of data that were collected for the NAPE program. And those are made available freely to through Azure open data sets. What I've done is embedded some raster functions so that we can change the way we visualize the data. And right here, I don't have any overviews generated. I'm really just using the primary rasters. So I do need to zoom in to actually see the pixels. So, but I have the ability to change the processing template and see it in a different way, just using the same imagery. So this is something, you know, a pattern that we can consider publishing from when we're using cloud data, whether it's open or your own. We can consider publishing a mosaic data set in that dedicated pattern. So right here, if we were going to publish image services with Image Online pattern, we would just upload the data. So let's take a look at some of that. Here in the ArcGIS Online organization, when it's been enabled for ArcGIS Image, you'll have the ability to create imagery layers and really just set down a visual workflow with this web user interface to decide what kind of layer you want to publish. Is it tiled or dynamic? Then you just choose how the individual images in what you upload get treated. If there's more than one, you may want to have a separate imagery layer or have them mosaicked into a single layer or create an image collection. Finally, you can specify anything you know about the incoming data, whether it's multidimensional, you know, or specify the provider that you know it's coming from. Otherwise, you can always choose raster, generic raster data set. In any case, you can define the kind of raster data it is, whether it's elevation or a thematic raster. You can decide how you want it to be processed with respect to overviews and footprints, or even defining a custom no data value. So all of those things you specify, and then you really just upload your data. and you can drag and drop it into this user interface. I'll do that here. It's just choose something here. Sorry for the delay, just trying to find something that was familiar. So here's a series of nape tiles that are adjacent to one another. And I just start that upload. And the final step is to just give the item information that you need for publishing that into your organization. So I'm not going to go through these steps. In the interest of time, I already have these layers published. So you can see, for example, the one I just started, here is this dynamic image collection. And see if there's any, there is a filter applied. So if I remove that, I can see these adjacent tiles have different colors. They're acquired in different years. So what I might want to do is just decide how I want to filter those and just look at the 2011 collection for historic purposes.
Dave,
so I can,
hey, Dave. Yeah, I
Yep.
think your screen's may be lagging a little bit. Maybe you want to stop your video and give yourself a little more bandwidth.
Thank you for that feedback. Just a moment. Okay. What frame are you seeing on the screen share?
We have the dialog box with dynamic image collection, HPF, NAPE, CO.
Okay.
Yep,
Okay, good.
you're up to speed now. It seems like it's moving.
Thank you. So yeah, I'll just choose a convention in the name that says it contains 2011. And when I apply that filter, this is kind of the nature of those dynamic image services is on the server side, it's actually assembling that response and providing the mosaicing that I've specified here. Okay, so let's take a look at a couple of other examples. This layer, the tiled mosaic and the dynamic came from the same exact content. It's just a single data strip coming from Airbus, and this is spot 7, not long after the fire broke out. And so the tiled mosaic, you can see how it renders as I zoom. It's pulling the full data model. So each one of these tiles, it's loading very fast, but it does give me the full pixel depth here that it's reporting in all 4 bands, and enables me to configure the image display options that I want to use. Just for color composite here, it's near infrared, red and green, and a stretch that I like. So these changes with tiled imagery are instant. It's all done client side. So for analysis workflows, it's a really good choice. In contrast, let's take a look at the same data set just as a dynamic mosaic. And you'll notice it didn't load as tiles. It just brought the whole extent as one. And one of the nice things about this, I mean, we still have the same capabilities as in the tiled layer, but here in the image display, I can choose from raster functions that are embedded in this service. So it's a nice way to expose this to your users so they don't even need to have the knowledge about how to set up that raster function or that band math. They can just choose it and apply it. Okay, so I did want to talk a little bit about the dynamic imagery pattern. So once again, this here where we're not uploading, it's already existing in one of these locations in the cloud. And so the way that works, you know, one of the examples is within Amazon, there are many open data sets. I'm going to take a look at the Sentinel-2. As a complement, to the provider data I got that's much higher resolution from Airbus, I may want to go back and just see what's available from the open satellite missions. So I can make an ACS connection to any one of these open data sets here, and I'll take the version that's using cloud optimized GeoTIFFs. Once I've done that, I wanted to point out another tool that you should look into if you haven't heard about this, Mosaic Dataset Configuration Script. It's discoverable just through a Google search, or if you look in GitHub, you'll find this repository. And rather than pour through this here, I'd rather show you how meaningful it becomes when you exercise it. So it's really a set of Python, and here I'm calling it from a command line. I just have to define a couple of variables where my Python environment is, the MDCS path, like where this is sitting on disk, and then I give it the name of a file geodatabase and a Mosaic data set. And when I run this, I'm also giving some parameters on a start date and an end date, a threshold of cloud cover that I'm willing to accept, and then a bounding box. So all of that together produces this automatically. It generates, okay, here. So I made a bounding box for the fire perimeter. And here is the resulting Mosaic data set that I brought in. And so we can see by looking at the footprints table that we got almost 50 individual acquisition dates for this AOI and over that time of interest. And so it's nice because we can take advantage of those renderers, have a look at the color infrared, and really have that stark fire damage delineated. Or we can take advantage of some of the middle infrared bands that are available in this sensor, and the shortwave infrared. We're able to see the fire damage in a different way and feed this in time, looking at the change over time as the fire advances. There's a lot we can do with analysis. And on that subject, I wanted to point something out here. Let's go to the Imagery tab, raster function chain. And let's say I wanted to maybe I just want to do a clip, so I'm going to search for that. So a clip raster function, and it takes as the input, it'll take my Mosaic data set, and I may want to just clip outside, and I'll use some geometry here of my AOI. So you can always persist these in memory as a layer. And that's something that you can do with this tool. It just populates a new layer into your contents pane. And it computes this dynamically. So now, if I turn off the source data, we'll just see the clipped information. What I want to point out is that you can also decide to persist layers. So if you don't want to manage this in memory, if you're authenticated with a portal or an ArcGIS online organization that has this, you can just persist new dynamic or tiled imagery layers as new services. Kurt, with that, unless there's anything else specifically you'd like me to touch on, I would hand it back to you.
Okay, thanks, Dave. I appreciate that. Any questions from the audience on what they've seen so far and how that can work? Dave kind of took a really, he showed some technical stuff. Dave, with that script that you were showing, the Python scripting, how would the user really use that? I mean, are they using that? Could that be set up to be constantly monitoring those cloud sources of imagery and updating local information as it comes in?
Yes. I'm glad you asked that question. Certainly. So as changes are being made, new satellite images are arriving almost daily from Sentinel-2. So we can take advantage of the ability to update a service in either this pattern, ArcGIS Enterprise, or ArcGIS Image Dedicated. We're able to reflect change and just produce an update on those. So the way that would practically work, let's just take a quick look here. So I've created another AOI. The first one that we looked at was just here for Cameron Peak Fire. We also had a nasty experience with the East Troublesome Fire around the same time. And so all I've done here is generate a bounding box that's in the right spatial reference. And using that here in the MDCS, I'll just show you how this works. I paste that in. I've modified the dates for start and end to cover that fire. I mean, that's really just coming from the incident web. Yeah, so here from the East Troublesome Fire, I can see that temporal window that I need to cover. And then really all we have to do is give it a unique name as a mosaic data set. But what happens if I just run this? We'll get some feedback, and it takes it a minute or so. We'll get some feedback as it generates the mosaic data set, performs a query against all the source open data, and begins adding that metadata to the mosaic automatically.
It just keeps populating that mosaic.
Yeah, so here we see the matching scenes for the Troublesome Fire with respect to geometry and time. And then we add a couple of custom fields, and it should be just wrapping up here. So the significance of this is that it's automatic and you don't have to think about content management in this case. We just run it again.
It just keeps going and going and pulling the latest information out.
Yeah, you got it.
So Lisa asks if, she liked the fact that it's able to do the analysis on the service and setting up that analysis on the service. Is there a way to persist that and be able to keep looking at it if you don't have access, if you still don't have access or use of the portal? So in other words, if you do analysis, can you pull that in locally and keep it in ArcGIS Pro or view it in a web map?
Yeah, certainly. So if you don't have the privilege enabled to publish this, into ArcGIS Online, know that any viewer type of a user in the organization can consume those. So, and once you can consume those services, again, I want to reiterate, they can come from any of these patterns, not only Image Online, but Dedicated or ArcGIS Enterprise. Once you have those, you can take advantage of that here. So if I'm in Portal, I can look in my organization and see that I can see all of those services are available here. So, Pro knows about the fact that this is a hosted imagery layer, and it reports that for tiled imagery, as well as the dynamic imagery layers. And you can bring those into Pro, create those raster function processing scenarios that you want to use, and and just persist the results locally as new layers.
That's the thing. So it's just a matter of selecting and it's saving out the result of that raster function as a new layer, and then they can access it over and over again.
Exactly.
Basically. Okay. Hopefully, Lisa, that answered your question. Is there any other questions that, from the audience? Feel free, type in. You can feel free to unmute yourself and ask a question directly. While we're waiting for questions, I do want to point out, and Nick is our host today. Nick is he's kind of being a quiet, silent partner, but he's the account manager for USDA. But he comes from a long background of image processing scientists. His dad led a significant effort at Goddard with the original Landsat program. And one of the things that Nick has recently completed, he's actually put together this story map of all these different image processing techniques and best practices. So I'm going to add this link now into the chat. So feel free to go in and take a look at this story map. I think it just provides a wealth of good background information about remote sensing and the different processes that are used. Nick, did you want to add anything to that?
Yeah, actually, the credit really is due to USDA ARS, Agricultural Research Service. They took this material and repackaged it in Imagery. It's been around for about 20 years and was mirrored on a bunch of different sites, but it has been upgraded, and this is actually the latest version out there. And it's a comprehensive view of remote sensing going all the way back to Hertz, which was Landsat 1.
I remember those original remote sensing manuals that ASPRS put out. I think it was a 2-volume set about as thick as a dictionary. So yeah. I guess it's been consolidated down and it's made available as an